Hello, my name is Quinten. I'm a first year Bachelor Mechanical Engineering student and this is my overall concept of the Hyperloop. This concept is my submission to the final assignment of the Hyperloop MOOC created by TU Delft and hosted on edX. The Hyperloop is a conceptual, futuristic mode of transportation currently being developed and researched by engineers all over the world. The Hyperloop is a fast and emission-free transportation mode mainly focused on reducing travel time. The Hyperloop concept is able to reach high speeds comparable to an airplane. In order to do so, the Hyperloop tries to eliminate or rather reduce two major speed boundaries currently limiting other modes of transportation. These two are air resistance, which is reduced by traveling through vacuum, and friction, which is reduced by levitation. To levitate a pod, a force must be applied to prevent gravity pulling it to the surface. This is achievable in different ways, mainly by using electromagnets in different configurations. For my Hyperloop concept, I will be using EMS, which stands for electromagnetic suspension. The concept of EMS is to repel surfaces using the same charge. In the application of the Hyperloop, the EMS is used to keep the pod levitated. The active coils are used to induce a magnetic field which levitates the pod. The flexibility of controlling the vehicle will be significantly increased. With active coils, the grab created by levitation can be modified and tilted, making it possible to change the Hyperloop's trajectory. It reduces friction on the track, thus reducing energy consumption. Though a very strong magnet is required to lift the pod, thus increasing the costs of the Hyperloop. To keep the pod in place at high speeds, thus keeping it stabilized, the coils are placed in a T-like foundation, which can also be used for propulsion and braking. Propulsion and braking. There are many ways to exert thrust, but for my concept of the Hyperloop, limbs are used, which stands for linear induction motor. This motor is a combination of linear motion and magnetic levitation, propelled by the magnetic field and the current. The limb has many advantages as a method of propulsion, especially in the application of the Hyperloop. The limb makes no contact with the surface and so removing the need of wheels at high speeds. By placing the limb on the track itself, no energy storage is needed for propulsion on the pod and thus significantly reducing weight and increasing potential volume for cargo, passengers or design applications. A big disadvantage of the limb is that it isn't as efficient, especially at low speeds. But this can be solved with other solutions. This is a basic concept illustration of a cross-section of the tube, with a two-way traffic application. The limbs are configured in a triangular order to improve propulsion. Even though this will significantly increase the cost of the tube, it supplies the required propulsion to reach high velocities. Since the limbs aren't ideal for fast accelerations and acute stops, wheels are used in the Hyperloop. These wheels can be used to support the pod while traveling at low speeds and can be used for friction braking, much like an airplane landing and taking off. Aside from the braking force applied by the limb, friction braking has the advantage to efficiently decelerate the pod within seconds, which makes it possible to remain in higher speeds for a longer period of time. Though the disadvantages of using friction brakes is that the wheels can overheat and wear down the track, contributing to higher maintenance costs. Systems and control. To regulate the position and speed, the controller system has to be aware of the position of the pod in the tube. This will be tracked by using sensors in the nose of the pod and the upper side of the tube. In the upper side of the tube, information is received and distributed to the controlling system. By keeping in permanent contact like this with the pod, exact position and speed can be determined and processed. The main disadvantage is that this is a complex technology and will increase the cost of the Hyperloop. The power is supplied by a centered energy cable connected to the limbs. This energy can be passively connected by using solar panels placed on the above ground tubes. Design and application. The chassis. The pod has to be light and strong to withstand external forces but reach high speeds. Aluminium and carbon fiber will be the best of use in this scenario. Even though carbon fiber is strong and light material, it's also expensive to produce. On the perspective of cost, carbon fiber will be scrapped out. But by making a reinforced composite of aluminium carbon fiber and adding honeycombs, the pod has a strong chassis and is able to sustain significant forces. Interior. The Hyperloop is a scary concept for the public. People are accustomed to the luxury of trains and planes, so to make a design for the interior, plane and train interior design can be an excellent inspiration. By balancing the cost and comfort, several design ideas can be made like charger plugs, displays with travel information or outside simulations, and onboard Wi-Fi. Safety. The most important factor of design has to be safety. Within the pod, only straightforward things like an AED, first aid kit, emergency brakes and escape airlocks must be in place. With the use of small algorithms, pods can be controlled for braking to prevent collision and emergency service can be automatically informed. At every 2.5 kilometers, an emergency exit is constructed on the tube for people to get out. The Hyperloop is a hyper-futuristic new concept. To win acceptation in everyday life, people have to trust the concept fully. Just like how it used to go with planes. Not long ago, people feared to fly in a vehicle at such high speed, but this changed over the years due to slow acceptance. With Hyperloop, it would be best to first test the infrastructure with cargo first, so if something goes wrong it wouldn't be a crushing blow to the idea of the Hyperloop. The location and interconnections of the infrastructure are of significant value to the cost and profitability of the Hyperloop systems. Transportation companies wouldn't make such a risky investment if it doesn't profit them. My ideal route would be London to Paris. These two metropolises have lots of people to be transported and aren't too far away from each other. The tube has to go under the canal, so a tunnel has to be dug. Since there already is a tunnel constructed there, it would be easier to design a Hyperloop passage. This was my Hyperloop concept. Thank you for listening.